Hi everyone. Today we're going to go over the lesson 38 practice set. We're dealing with interpreting graphs. So let's get started. For letter A, how many more tires were sold in February than in January? So when we're looking at a graph, the representation of the data can vary depending on the graph. We have bar graphs, pie graphs, pictographs, line graphs. So some of them are better for some things than others. In the instance of pictographs, we can use them to compare values between a varied set of data. So typically with the pictograph, you also have some kind of picture or symbol that represents the value as opposed to a number line or an x-axis or y-axis that shows you the numerical value. In this instance, we have symbols, and the symbols represent their own set of values. So each of these tires is represents 100 tires sold. So going back to the question, how many more tires were sold in February than in January? What do we need to know? Well, we need to know how many tires are sold in February. So we have to count the tires in the pictographs. We have 1, 2, 3, 4, 5, 6. So that tells us that we have 600 tires that were sold in February. And we also need to know how many were sold in January. 1, 2, 3, 4, and if each of those represents 100, then 100 times 4 is 400. And the question is asking us how many more were sold. So since we're comparing the two values, what we need to do is we need to subtract them. So you have 600 minus 400, and that will tell us how many more tires were sold in February than in January. And that's how we can use a pictograph to kind of compare values and then see what the pictograph is telling us. Important thing to note with pictographs is that there's a legend that tells you what each symbol represents or the value of each symbol. So that's always something you need to look for in a pictograph, because otherwise, without the legend telling us how many, we have a ratio that we could use. Like we could say, in these 3 months, we have a total of this many, but it doesn't give you the exact value of it, which can make it difficult to solve problems where we want exact values. And it's also important to look at the legend, because otherwise you're thinking they sold half a tire or they sold the letter C, either one of which, probably wouldn't make sense for a tire shop to do. All right, for letter B, we have a bar graph. And bar graphs we can use to compare values between unrelated, well, not unrelated, but different sets of numbers. Now, the comparison here is a little bit different because a bar graph actually uses numerical scale as opposed to symbols to represent values. So while it serves a similar function to a pictograph, what makes it a little different is the fact that we're actually numbering the value of the bars, as opposed to just having pictures that represent values. So this bar graph tells us about the number of aluminum cans collected by each homeroom. Now, the room number here, that's something that we have to look at. The room number here is not an actual value. It's much the same as saying this is the elephant room, this is the lion room, this is the tiger room, this is the zebra room. These numbers don't actually mean anything in terms of the data that we're looking at. They're just representations of the group. So going back to the question, how many cans were collected by all 4 homerooms? We have to look at how many cans each homeroom collected individually, and then since we're looking for how many were collected in all, we would combine those values. So looking at the graph, room 12 looks like they, about 5,000 sold or collected, sorry. Room 14 goes all the way up to 8,000, and I'm using K for 1,000 mainly because it's a chore to write down all those zeros using this computer. For 16, you can see that it goes about halfway between 8,000 and 10,000, which makes it 9,000. And again, the K represents 1,000. And then for room 18, it looks like they collected about 4,000. So to find how many cans were collected in all. We just have to add 5,000, 8,000, 9,000, and 4,000. And we were able to identify the value of each graph by just looking at the left-hand side here. Again, these numbers at the bottom are not it. These just tell us the individual groups that they belong to. It doesn't mean that there's 12 students here or 14 there or what have you. Looking at a line graph shows us change over time. So it's kind of a progressive change, incremental change from one to the other, from one data point to the next. So it could kind of show you over time how things increase or decrease. While technically there's no, the scores from game one don't affect the scores from game two in any way, you can kind of see the change that occurs as this person bowls from one game to the other. So in which game was Paul scored lower than his score in the previous game? So what we're looking for is a data point where we have a lower score than in the previous game. So you would think that, game one would be the obvious contender, but there was no game before game one. So that's not going to be it. So we're looking at a game where he scored less, his score dropped, not increased. You see a kind of steady increase from games 1 to 3, but then from 3 to 4, his score actually drops. And then you see another increase from 4 to 6. So his score was lower in the fourth game compared to the third game. And that's the only time that you actually see a drop in the graph. Otherwise, it seems like he's kind of getting better, either with more practice or maybe he gets a little tired and he caught a second win. Who knows if all these games are consecutive, right? I think personally, I've only ever bowled 4 games in one sitting. But other than that, maybe he just went one game each, which doesn't make sense. You bowl a game, you wouldn't want to just bowl one game and then leave. So maybe these are all just in one sitting. He was doing decent. Maybe he got a little tired, picked up his second win. But it would be game 4 that you see a drop from the previous game. Letter D. We're using a pie graph here. So pie graphs or circle graphs tells us about the relationship between parts of a whole. So part of it in comparison to the entire thing. It gives you an idea of how much of visual representation of exactly how much rate of the space your data point takes up in comparison to the entire data point. Usage rates in the NBA would be one that I think would qualify because that serves as a percentage. And what a usage rate is, in very basic terms, is the amount of possessions that one player uses compared to the rest of the team or compared to the entire team. So you'll see that players that score a lot of points, have the ball in their hands a lot. They typically have a higher usage rate than some of the other players on the team. But that's neither here nor there. What fraction of Aisha's day is spent somewhere other than at home or at school? So what we're looking for is a fraction that represents the whole. In order to do that, we need to know what the entire whole is, which is 12, 8, and 4. So a combination of these would be 24 hours that she's spending total, which makes sense because there's 24 hours in a day. Now, what fraction does she spend somewhere other than at home or school? So you look at the time she spends at home. We don't want to look at that right now. The time she spends at school, we're also not looking at that. So then let's look where she spends her time elsewhere. And that's going to give us 4 hours of her time that is spent in other places that are not home or school. Now, with all fractions, unless you're using it for something specific, you want your fraction to be simplified. So make sure that you divide by the greatest, the greatest common factor. And then that'll give you your simplified fraction of where Aisha spends her day other than at home or school. For E, which type of graph best displays the relationship between parts of a whole? Well, we just went over that, right? In a circle graph, again, this does it because you can kind of see relative to everything else how much one part takes up compared to the rest of it. So you can without having to calculate anything mentally like you would have with the pictograph or a bar graph. You can see the relationship between the two sets of values. So that's what you want to look at when you're talking about parts relationships between parts of a whole, is a circle graph for E. For F, which type of graph best displays changes over time? Uh, you know, when we're talking about the weather, for example, and plotting how the temperature falls and rises day to day, or even precipitation month to month, a line graph, would be an excellent choice there. So a line graph is definitely the best graph that you can use to display how something changes over time or from one data point to the next. We wouldn't use a bar graph because in the bar graph, again, you have groups that you're comparing, which brings us to G. Which type of graph is best for showing comparisons? Bar graphs are good because they give you a very quick idea visually of how something is larger than something else. But pictographs are also good for comparing because it gives you symbols that you can visually look at and then see how they compare to the others. Uh, so both of those are good for comparisons. So this has been our practice set for today. If you have any questions, please comment in Classroom or leave a comment. If you found this video useful, hit the like button and subscribe. And be on the lookout for our next video, which will be Lesson 38 Homework Help, and any other future videos that we might use. So hope you have a great day, and we'll see you later.